Good morning, honorable judges. First of all, I would like to inform you that this presentation outline consists of problem identification, titles and theme introduction, solution explanation, conclusion, and closing. We all realize that there is an abundance of renewable energy potential in Indonesia. Indonesia has a target of electricity generated from renewable energy power plants in 2025 of around 115 gigawatts. But the transition is hampered by various factors. The main factors that has significant impact is the policy. Currently, production relies on the PPP, which is based on the historical calculation of electricity production cost. This is not relevant to renewable energy technology, which is getting cheaper in the future. Besides that, the feed-in tariff regulation was being discussed by the government. However, feed-in tariff has a staging mechanism which disables the negotiation process. In addition, the option of the highest benchmark price makes it more difficult for the government to control finances. On the other hand, renewable energy companies are new companies with developing technology, such as Pertamina Power Indonesia, that has been founded in 2016, and also Pertamina Geothermal Energy, which is founded in 2006. These companies are still very young compared to oil and natural gas companies that has been founded 100 until 200 years ago and are already have highly developed technology. Therefore, we believe that fixing the policy is the best way to support new renewable energy companies, such as increase the investment and technology development in order to reach 23% of target of renewable energy generation by 2025. So, my name is Fauzan Husna, and here are my colleagues, Puja, Chandra, and Kenshi. We are from Yundeep team from Diponegoro University. As agent of change, we would like to present you our solution under the title Increasement of Renewable Energy-Based Electricity Production using Combination of Budget Subsidy Mechanism, Reverse Auction Cost Estimation, and Implementation of Taxes on Coal and Fuel Oil for Development Fund.
Hello, I'm Puja. Let me explain to you about the solution. We offer two solutions for this case, namely this budget subsidy mechanism, reverse auction cost estimation proposed by ASEAN Bank Development 2020, and the implementation of taxes on coal and fuel oil for development fund proposed by IESR. The first solution is the subsidy budgeting mechanism. As you can see on the diagram, it begins by calculating the annual subsidy by PLN based on the estimated sales of electricity from renewable energy existing power plant, also considering the planning for RA new project in the future. The amount of subsidy is based on final true-up. What is true-up? True-up is the adjustment of journal to meet the actual generation or electricity revenue by RA power plant. True-up is done at the end of the year for the difference between forecast and actual or audit. The equation and mechanism will be explained later on the next step. So the next step, after the calculation by PLN, annual subsidy value will be verified and reviewed by ESDM, Minister of Finance and the House of Representatives or DPR, to ensure that they do not exceed the economic ceiling. After being reviewed, the value of subsidy will be included in the APBN. The next step is granting of a fund subsidy, which is 95% of fund carried out arrear on a monthly basis. Then, at the end of the fiscal year, PPK will audit the profit gain. If electricity revenue is less than the estimated value in the APBN, 5% of fund will cover the price difference. However, if electricity revenue is more than 5%, the fund will be carried out forward for the next year budget. As you can see on the slide, this is the reference formula used to calculate subsidy. From this formula, the important thing to note is avoided cost and projected sales or cost. Avoided costs consider the external benefit of renewable energy as the concern of subsidy budget calculation. I want to give you simulation case calculated by ASEAN Development 2020. If we try to replace coal-fired power plant with thermal efficiency, let's say 42%, with a 55 megawatt geothermal power plant in the Java Bali region, the benefit is reducing the cost of pollution. For example, handling particulate matter with 2.5 micron is cost around 6,000 USD. Nitrogen oxide is cost around 3,000 USD, and sulfuric oxide is cost around 5,000 USD per ton handling. RA also afforded us from unexpected deviation of oil risk prices, lower health subsidy, and other benefit stated in the form of rupiah per kilowatt hour as shown in the table. Besides avoided costs, there are also projected sales or costs which minimize potential disagreement in RA project because it gives more price and gives a good position as the renewable technology in the future become cheaper. Reasonable project pricing can be done through reverse auction and cost estimation. As you can see on the slide, the reverse auction determines the developer based on the developer price proposal, which will be sorted from the cheapest to the most expensive, and PLN will select the lowest price. The developer who conducted the reverse auction fulfill the administrative, technical, financial review and portfolio required, and already been reviewed by PLN. The reverse auction is suitable for power plant with easily identified potential. For example, solar panel, as the construction risk and electricity production are easily known.
Hello, my name is Kenzie and I will show you the cost estimation mechanism besides reverse auction with easily known potential. However, there are also renewable energy sources whose production is more difficult to predict. For example, the geothermal power plants, because they are very dependent on the risk and exploration results from the developer. Cost estimation methodology calculates the price based on the crucial project parameters like resource size and quality, and also consider factors outside the developer. The pricing will follow the minimum acceptable price contour that shown the minimal price but acceptable by the developer, in contrast to the fit-in tariff, which is indicated by a flat line. Cost estimation avoids the government from excessive payments. The price agreement will be made through the PPA by agreement between renewable energy developer and PLN or government. If the PPA price results from a competitive tender, then the renewable energy project cost used for subsidy calculations is capped at the economic value. If there is no competitive tender, then the allowed renewable energy project price is capped at the lower threshold of the estimated production cost or economic value, calculated separately for each renewable energy technology and PLN grid.
Hello, my name is Chandra. I will show you our second solution, that is the implementation of tax on coal and fuel oil to obtain development costs. Both coal and fuel oil follow the lowest percent scenario, which is scenario 1. According to Muhardi 2005, the implementation of tax will increase the fuel price, which has implications for Indonesia's macroeconomic fundamentals. Choosing the least percent will give the least impact. Scenario 1 of coal tax consider caloric value or CV for each type of coal. 1% for low CV, 2% for medium, 3% for high, 4% for very high. By doing scenario 1, Indonesia will gain 525 till 527 million US dollar for the RE development around 2018 till 2050. Besides coal for fuel oil with flat tax 20.5%, the projection, if we consider the increase in usage by 2025, the revenue obtained is 878 million US dollar for scenario 1. Based on this study, Pertamina, along with another renewable energy developer, will play a role in expanding electricity supply capacity through renewable energy projects obtained through the reverse auction cost estimation model. Besides, the tax on coal and fuel oil from sales can be used to develop renewable project according to scenario one which will have the lowest impact on the economy. Thank you for the attention. Please ask if anything is unclear.